One of the reasons we set up this channel was because we were asked to share some videos we'd made for friends on how to install an electric fence. Well, we put together an introduction to the whole topic, and it covers all the components of an electric fence, what they do and how they work. But if you're planning to design, buy and install an electric fence, there's a lot of options to look at. So we want to do some videos that look at a certain area of electric fencing, lay out the different options and help you choose the right components for you. Today, we're going to cover the different ways to power an electric fence. Hello, welcome to English Country Life. My name's Hugh, welcome to the chicken enclosure and welcome to powering your electric fence. Now, if electric fencing is an entirely alien concept to you, we have made an introduction to electric fencing and I would suggest go and look at that first. It covers all the components of an electric fence, how they work and how the fence as a whole comes together. Today though, we're going to focus on powering your electric fence. There's a number of different approaches, there's a number of different power sources and there's sizing options to consider according to how big you need your fence to be. So stay with us, we'll guide you through them and hopefully help you choose the right components for your setup. Before we get into the components of powering the electric fence, let's just take a couple of minutes to remind ourselves exactly how an electric fence works. The easiest way to understand the correct functioning of an electric fence is with the aid of a diagram. So let's start building one up. To start with, what we have here is some grass and some earth, and both of those are an important factor in the correct functioning of your fence. Now we've added some poultry mesh, and you can see there's a blue band that I've shown at the bottom, and that's the part of the mesh that can touch the vegetation because it isn't carrying any electricity. All the horizontal strands above that are the ones that will be live and will carry electricity. Now we've added the energizer. Just as in real life, there's a lead connecting the energizer to the mesh and another connecting it to the earth spike. The energizer is sending pulses of high voltage along the horizontal strands, other than the blue shaded strands, of the poultry mesh. And the current wants to come from those strands back through the earth into the earth spike. But there's no connection between the horizontal strands and the earth until a predator comes along. And if that predator touches one of the horizontal strands and the earth at the same time, the pulse of high voltage allows current to throw through the poultry mesh, through the predator, into the ground, along the ground and back up the earth spike. And that completes the direct current DC circuit that an electric fence operates on. So in its normal state, there's a break in the circuit. The fence does not touch the ground and both of those are, if you like, wires. And when the predator connects the wire that is the fence to the wire that is the ground, current can flow through the fence, through the predator, through the ground and back to the energizer. Interestingly, if a little bird lands on top of your fence and isn't touching the ground, it won't receive any shock at all because it isn't completing the circuit. So the heart of your electric fence is your energizer, and what that does is puts out pulses of high voltage, low ampage, low current electricity, and it pumps them into the electric fence. That goes nowhere until something connects the live part of the electric fence to the ground, and then the electricity flows through the fence, through what's ever touching the fence, into the ground, back to the energizer, and whatever it is that's completing that circuit between the live part of the electric fence and the ground gets a shock. That's how the energizer works. Now there's different types of energizer, so let's have a look at it up close and we can describe the different options, the different types of energizer, and we can think about what's the right one for you. I want you to notice that green light in the middle at the top that's blinking. Every time that light blinks, the energizer is outputting a pulse of high voltage electricity, and that pulse would go through your electric fence. So your electric fence is only live when that green light is on. It's not constant. There's a little pulse of electricity, 1, 2, 3, like that, going through the fence. And when a creature touches it, if it touches it briefly between pulses, it won't get a shock. There's really only 2 major considerations to think about in terms of your energizer. There's power coming in here, and we can think about where we want that power to come from. Do we want it to come from a battery? Do we want it to come from the mains, etc.? And there's power going out when it's connected here, going through your fence. And there's a question of how much power out does your energizer need to have? Bigger fences, bigger setups require more power. And we'll look at both of those considerations independently. Let's first think about the power out. So we understand that we need different types or sizes or power of energizer for different amounts of electric fencing. Now this energizer says 2.4 J on it. That's 2.4 joules. That's a measure of its electrical output, the amount of power it's outputting. 2.4 joules means 2.4 watts per second. And if you're not clear on what watts and amps and volts are, do watch the introduction video. We explain it all in there with some visual aids. Now, a kettle uses 3,000 watts of electricity, or more or less, but that's quite a normal kettle, 3,000 watts of electricity. So if this is putting out 2.4 watts per second, it's a tiny amount of electricity by comparison. Now, a tiny amount of electricity at high voltage is quite painful. It's like a bit like that static shock you get when you get out of a car and you've rubbed your feet on the nylon carpet. Not a lot of electrical power, but quite painful. That's roughly how an electric fence works. But how much electric fence will that power? Well, poultry mesh, the kind of electric fence we want for chickens, comes in a number of lengths, usually 50 or 25 metre lengths. You can occasionally find 16 metre lengths. And that energizer will run up to 200 metres of poultry mesh, which would be sufficient for quite a large enclosure. 50 metres may sound a lot, but that's only a square 12.5 metres on each side. And actually, when you look at that on the ground, that's not very large at all. So 200 metre length of fence, yeah, that will enclose a reasonable amount of land. There are other sizes of energizers. So this particular range, which we use and we quite like, the Gemini range, they also do a 1.2 joule sized energizer, which can run 3 50 metre fences, 150 metre, but that's in ideal conditions, assuming that there's no undergrowth touching the fence, there's no minor shorts, etc. For safety's sake, I would say use that on up to 100 metres, maybe 125 metres of poultry mesh. And there is a 0.8 joule one, which again is claimed that in under ideal conditions can run 100 metres of fencing. I would tend to use it for 50, maximum 75 metres of poultry mesh. Those are the sort of areas. Now, if you're ever running the stranded type of electric fencing, which comes in many variations of wire and tape and rope and so on, you can cover vast distances with a 2.4 joules. Because those tend to be up in the air, away from anything that might be touching them or shorting them, etc. Strand type electric fences, one of those can, in theory, ideal circumstances, run about 18 kilometres of stranded electric fence. Now, normally you'd have sort of say 3 strands or 4 strands. So if you said a 3-strand fence, in theory that would be a total of 6 kilometres of length. Conditions are rarely ideal, but could it run a kilometre of 3-strand electric fence? Absolutely it could. So it's very different when you're looking at mesh fencing compared to when you're looking at stranded electric fencing. The amount of distance that you get for each type of energizer is very different. But that's how to size them. Now, I would suggest that when you buy one, if you're not sure what size you want, go up rather than down. A lot of us start with a small enclosure for chickens and eventually we decide we want to have more or different types, different breeds, and we tend to want to expand what we're doing rather than contract what we're doing. Now, If that means just buy a bit more poultry mesh and splice it in because your energizer is big enough to cope, that's not a big deal. If you've got to, though, actually buy a new energizer and new mesh, that becomes considerably more expensive. So err on the side of caution, get slightly larger than you think you might want initially. How do we get power into the energizer then? Well, this energizer, as it says quite clearly, wants a 12 volt DC direct current input. In its simplest form, we just connect a 12 volt battery to the energizer, and as you can see from its little green flashing light, it quite likes that and it starts to flash away quite happily. This one though has another option. We can connect it to the mains, and as you can see, it flashes away quite happily there too. Now how it does that is this little device is a transformer. What it does is it takes the 230 volt alternating current in the mains and transforms it into a 12 volt direct current for the energizer. So the energizer honestly doesn't know whether it's on mains or whether it's on battery, because either way there's 12 volts DC coming into it. So why would you choose one of those two options, mains or battery, over the other one? Let's talk about that for a bit. So what's the pros and cons of having your energizer on mains electric? Well, the upside is you plug a lead in the side, you plug the other end of the lead into a socket, and the energizer just chunters away to itself, and that's it. Great. Yeah, the downside is the transformer and the energizer itself have to be inside, indoors, in a building, protected from moisture, etc. So it could be, if you've got mains power to them, in a barn or a shed or a garage or anything like that. Could even be in your home. But of course your electric fence is outside. So how do you get around that? Well, what you have to do is use this stuff. This is called lead out cable. Really thick, a 2.5 millimeter inside core on that, about 8.5 millimeter thick wire for a single strand. And you need two of them. One that goes to the earth spike, one that goes to the fence itself, wherever you want to bring power into the fence. And you run those wires to wherever you've got the energizer, and then all the way to the electric fence. We've done it, and I'll show you a couple of stills in a minute. We buried the wire underground in a trench to do that. So let's take a quick look at some still photographs of how we did it. This is the trench that we dug for our lead out cables. It's about 2 foot deep to keep the cables out of harm's way. We took the turf out very carefully so it could be replaced later. All the soil we put onto a tarpaulin, you can use an old board, so that it doesn't kill the grass and doesn't get lost and can be easily replaced when the time comes. We brought the cables out at a post where we plan to put the electric box about 20 yards from the property where we plan to put the chicken enclosure. And by the time we put the soil back in, replaced the turf and watered it, I think you'll agree, after a week or two, no one's going to know there was any trench there. That's how we ran lead out cables, so that we could put mains powered energizers on our electric fence system if we wanted to. It's a good way of doing it if you're sure that there'll only ever be one place where you want to bring power into your electric fence system. I've known someone who did it really well, and they had horses and they had their paddock area divided into multiple areas, but they weren't ever going to change those multiple areas. They were on permanent posts, and they could move the horses from one area to another to rest the grass, but they weren't ever going to change the layout. They kept their energizer in the tack room, in the stables, permanently wired into the mains, and it's how they managed their electric fence, and it worked well for them. In a poultry environment, if your garden is of such a size you're only ever going to have the chickens in one place, again, then yeah, sure, why not consider putting in a main system? You know, you're never going to have to lug heavy batteries around, you're never going to have to charge batteries. Unless there's a power cut, you really shouldn't have much of an issue. It is very much a viable consideration. It is worth pointing out as well, when you're making your purchase, some energizers are battery only, Some energizers are mains only, and some energizers can take either power source and come equipped to do it. So give some consideration to, am I certain that I want to go battery? Am I certain that I want to go mains? Or might I want to build some flexibility into my purchase that I can do either in the future? Battery types. First, let me just get a sort of caveat out the way. There are some energizers that run on all sorts of oddball batteries. So there are some that out there that run on 9-volt internal batteries. There are some that run on 6-volt square disposable batteries. There's even some that run on sort of D cells, the kind of batteries that run a mag light, that are intended to be almost throwaway. Generally, the ones that run on anything other than 12 volt are intended for fairly small versions of electric fence and often as sort of temporary measures, etc. But they are out there, so be careful. I'm talking here about the mainstream energizers that run on 12 volt batteries. And there's two basic kinds of 12 volt batteries. There's leisure batteries, which this is, and there are car batteries. And car batteries are intended to produce a lot of current for a very short space of time to start the car, to work the starter motor. Leisure batteries are more intended to be used for the electrical fittings in motor caravans, motor homes, RVs, that kind of thing, and intended to run the lights or the music and that type of thing. So smaller draw for longer periods of time. And your energizer ultimately is going to want a smaller draw for a longer period of time. But either kind of 12 volt battery will work. It's just if you're going out to buy one, the leisure battery is more suited to what an energizer is going to want. But our great friend engineer Dave, who does a lot of vehicle restorations, often has lots of car batteries kicking about the place. He's run his electric fence on old car batteries for decades without problems at all. They don't necessarily last terribly long, but if he's doing a restoration, he's probably got a few of them lying around anyway. So when they fail, he'll get rid of it and replace it with another one. Either works, but if you're going to buy one, I would tend to buy a leisure battery rather than the standard car battery. Let's talk a little bit about battery size. This is our 12 volt battery, and I want to show you the label on the top. Just here, it says 115AH. That stands for 115 amp hours. In other words, at 12 volts, this can put out 1 amp for 115 hours. Now, our 2.4 joule energizer, bear in mind it's only pulsing, is on average consuming about 200 milliamps, a fifth of an amp. So let's do some mathematics there. If this can put out 115 amp hours, and we're only actually using a fifth of an amp, it can run for 5 times 115 hours. Or if you like, a bit over 3 weeks. That's for our fairly powerful 2.4 joule energizer. If you were using a 0.8 joule energizer, you'd be looking at a draw of about 85 milliamps according to the specs. So that would last more than twice as long. You'd get over 6 weeks out of a battery this size. Now we've spoken about you've got to size your energizer to the amount and type of fence you want to run. And we've now covered you've got to size your battery, the type of energizer you've got, and how frequently you're going to charge your battery. And there's really 3 charging strategies that I want to talk to you about. But before I do, let's touch on battery charger. This is a good quality bench type battery charger that I use, and it's great. But what it has is the ability to detect when the battery is fully charged. And good quality modern battery chargers should all have this. It's either known as maintenance charging or smart charging, because it's perfectly possible to overcharge a battery and damage it. And what good quality chargers do now is detect when the battery is full, switch into a different charging mode, and just keep topping it up, not trying to ram in more current than it will comfortably take. So do ensure when you're buying a charger that you buy one with maintenance charging or smart charging facilities on it. It'll do you a favour in the long term. So you can just have two batteries, one running the fence, one on charge, and every week swap them over, swap them back, so that you've always got a fresh battery on and you've always got one on charge. I've seen a manufacturer who makes a system for that, and I think it's called use one, charge one, something like that. I've only seen them once, but it's great. Two matched batteries. I think they're about 35 amp hour. You keep one on charge in your workshop, one running the fence. They're fairly lightweight, so they're relatively easy to swap them backwards and forwards. What a great idea. So that's your option one, two batteries, charge and swap routine. Option two, on a dry day, take something like this. This is a small, light, smart charger, and charge the battery in situ while it's still running the fence. Now, to do that, you must have a properly installed outdoor power source with a weatherproof socket to do it, and obviously do it on a dry day. But why not? You can charge the battery and use the battery at the same time. Or you can do what we did. Build an electrical box, a weatherproof electrical box with properly weatherproofed sockets inside it. And in that box goes your battery, your energizer, and a smart charger. Keep the smart charger constantly connected, constantly powered up, and it's constantly charging the battery. If you get power cut, so what? The battery on its own will run your installation for 3 to 4 weeks. As soon as the power comes on, it just starts charging the battery again. No problem. It's like an uninterruptible power supply for a computer. Option 3, though, doesn't rely on having that properly installed weatherproofed outdoor socket, etc., which you won't have in a lot of fields, let's be fair. So option 3 is solar charging. Solar panels are becoming more and more affordable, more and more accessible, and it is perfectly possible to build yourself or to purchase a solar setup that you can use in a remote field miles from any mains electricity to recharge the battery for your energizer. In fact, there are some energizers that come with a built-in solar panel. Now, to be fair, most of those are fairly small solar panels and they will be topping up the battery, but it will probably still need a mains recharge intermittently. But if you build one yourself, you can make it big enough that it will definitely keep your battery fully topped up. I'll show you both our electrical box and our solar panel. Let me show you then what's inside our battery box. Here, just hung on a simple screw, is our energizer. From the bottom of the energizer, 2 leads lead out underneath the box. One goes to the earth bond, one goes to the fence itself. The energizer is connected to a large leisure battery here, and there is a battery charger constantly charging that leisure battery. The battery charger is plugged into a proper outdoor weatherproof socket. That comes out to a long lead, and that plugs in to a garden weatherproofed socket. This is our homemade solar panel charging station. It's a small solar panel screwed to a piece of plywood. That plywood attached to a 3x3 75 by 75 fence post. And the fence post is attached to a bracket which is bolted onto a very heavy paving slab, and that allows it to be set up anywhere on flat, level, hard ground. If we want to put it on soft ground, I've shown a spike which we can just undo 2 bolts on the bracket that's on the paving slab, lift out the fence post, bolt it into this kind of a spike, and that spike can be knocked into soft ground so the charging panel can be put anywhere we choose to put it. Now, what I would like to show you is the method by which the panel is attached to the post, because that's important, and I'd like to show you how we use it to charge the battery. This is the bracket that I've used to attach the panel to the post. It's actually designed for a flat screen TV. But what it means is we can adjust the panel left to right, but also change the angle, either making it more or less steeply angled into the sky. so that in the winter it can point lower, in the summer it can point higher, and we can ensure that from sunrise to sunset it's pointing roughly towards the sun to get the maximum benefit from the solar charging system. This is the last part of our solar charging setup, and it's an important one. It's called a solar charge controller, and it does the same type of thing as the smart charging capabilities of the mains powered battery chargers we looked at earlier. It will detect the charge level of the battery and it will prevent overcharging. There's clearly a lot to talk about in terms of solar power, and I don't intend to go through it all in detail in this video, but I hope that's given you a flavour and shown you that it's perfectly possible to put together a solar system that will charge your electric fence battery in the middle of a field without any sort of mains. So let's take a quick look at earth spikes. What's an earth spike? Something like this. Chuffing great bit of metal hammered into the ground that conducts electricity through the ground, back through the spike and back to your energizer. It needs to be long, probably at least 3 foot a metre long. This, if you've ever seen them, it's called a fence pin or a road pin. And you can hammer one of those into the ground. It only costs like a couple of quid each. That'll work very well, as will a good long bit of old angle iron. Anything like that works fine as an earth bond. You don't have to spend a lot of money on earth spikes. Honestly, any bit of conductive metal that's long enough, hammered deeply into the ground, will work. Why has it got to go in deep? Well, in the summer, the top part of your soil will dry out from the heat, and dry soil doesn't conduct electricity very well. Wet soil does. So if you've driven your pin in really deeply, it'll always hit some wet soil further down, and that will really help the efficiency of your electrical system. And I'm going to show you another little technique that helps it even more in just a moment. So here's my sneaky tip to make your earth spike work more efficiently. If you can see that sort of L-shaped piece of metal that's hammered well in, there's 3 foot of that underground. First thing to note is that's a commercial earth spike, and they do work well, and one advantage they have is they're generally corrosion resistant, so that's been in for a number of years, not a bit of rust on it. And you can see the black cable leading out from underneath the box connected to the earth spike. What's less obvious, but if you look closely, you can see a second cable at the bottom left hand corner of the screen leading away from the earth spike. And what that does is connect to a second earth spike. So I have 2 earth spikes connected to each other. Why? Well, in a dry summer, and this area does get very dry, we can have 6 weeks without rain, that gives me a much better chance of a good connection. And if it's really dry, I will come over here with a watering can and put a watering can full of water around the 2 earth spikes to really improve the dampness of the soil around them and help improve the efficiency of the system. So that's my top tip for putting in earth spikes. And that is how to size the power requirements for your electric fence. I know it's a little bit involved, but just think there's 4 main questions you've got to ask yourself. How big do I need my energizer to be? Do I want mains or do I want battery? If I want battery, what size of battery is right for me? And fourthly, what are my battery charging methods going to look like? Once you've answered those 4, you've got it right for your installation. I really hope that's been useful for you. If it has, could you spare us 5 seconds and give us a thumbs up down below? Would you like to see more on electric fencing? We could do a similar video on the right kind of fencing for you, how to size it, how to measure your installation, where do you want gates, what kind of poles are right for you, all that sort of thing. We could do one on fault finding, how to detect a short, how to fix a short, all those kind of things. If you'd like to see that, or any other topic on small holding, on self-sufficiency, self-reliance, please let us know in the comments. We love to hear from you. If you'd like to see more videos from us, hit subscribe, hit the bell next to it, and you'll hear every time we upload a new video. But whatever you do, come back and see us soon. Take care.